Okay, this is not an exaggeration and it's not sarcasm. Word problems in trig are by far my favorite thing. If this had been like a normal year, right? No COVID, no weird pandemic and stuff. And I'm not minimizing that because it's a very serious issue. We would have been probably doing trig for 2 months, and the most of that would have been spent solving problems, not like this even, because this is like very easy compared to what we normally would do, but very complicated, interesting problems that actually model the real world. However, given our time constraints and trig was very fast, we're going to be limited. Now, that doesn't mean that you should forget or misunderstand that the whole point of trigonometry was to do problems like this and much, much harder problems like this. Trigonometry means how we measure triangles. Geometry is how we measure the world, and we actually measure the world mostly by using triangles. So future engineers, future physicists, future architects, this is your jam right here. This is your bread and butter, using trig to find unknown values and unknown angles. A bunch of other fields too, but those three come to mind, okay? Now, in general, we're always looking for a modeling right triangle. In other words, in the picture or in the story, we should be able to draw a right triangle and then do something to solve it. Now, I'm not going to lie, the first 3 or 4 problems here we're taking as super easy, and we're giving you the triangle. But the last 5 or so problems, you're going to have to draw it yourself, and so we definitely need that practice. Okay, with that being said, let's jump into this one. We have the picture for us right here, but let's read it anyway. You want to find the angle of elevation if you are standing 400 feet away and the building is 850 feet tall. Now, these terms, angle of elevation, angle of depression, are super important. What you should note is if you have an angle of elevation, okay, or an angle of depression, you always start from straight forward. And sometimes you have to add that to your drawing, okay? And so what I mean is, if we start looking straight forward, okay, this is our starting. Okay, so we start looking straight forward. This models something that humans do naturally. Like if you've ever driven or ever walked or anything, your natural place to look is straight ahead of you. You typically don't look down because that is actually perceived as weird. Like imagine you're walking around the park or walking around the school when you guys finally get back, and like if someone's in the hall staring straight down and walking around, they're gonna look weird because that's not how people normally walk. And so their natural equilibrium point is always straightforward. If we then, from that point, look up, okay, this is what we call the angle of elevation. Sorry I'm writing so slow, my board can't handle me writing faster than that. And so angle of elevation implies that you were looking one way and now you are looking up a different way. Okay, the thing to keep in mind is always straightforward and then up. We might as well talk about angle of depression at the same time. Angle of depression also starts looking straightforward and then looks down. This is probably the more misunderstood one, and we'll see some examples for sure about this. But this is angle of depression. Whew, okay. And so the thing that you should always keep in mind, if you're talking about angle of elevation or angle of depression, you are always talking about something shooting straight forward and then either looking up or straight forward and then looking down. Now, having said all that with that huge introduction, let's go back to the problem. We were told that we need to find the angle of elevation. Well, look at this. So we have something where we start looking straight forward, okay, and then we end up looking up. Okay, and so X is my angle of elevation. Now I'm going to abbreviate A of E simply because my board cannot handle me writing this very much right now. Okay, well this should look super familiar. I have a right triangle, I have an unknown angle, and I have 2 side lengths. Well, guess what? We're going to do some trigonometry. In fact, we're going to do some inverse trigonometry because we don't have the angle. I mean, you can find it. And so we have our angle of elevation, which is also going to be our reference angle. And so we should label the side lengths. Well, this is going to be my opposite side length. And then this one along the bottom, that's going to be my adjacent side length. In fact, we just did, like legit, if you were watching the videos with me, we just did like 12 of these in a row. And so this should be pretty straightforward. Okay, if I can get my board to just work with me a little bit longer. Okay, So we need to set up our trig problem. We have a reference angle, we have our ratios. Okay, so my reference triangle stuff, my actual triangle stuff. Okay, so we need to set a ratio. I have opposite and adjacent, so that's going to be O over A. Okay, for both sides. That does use a reference angle of X. All right, so over A by rule, that's still tangent. Okay, and if we reference X degrees, on our actual triangle, the opposite side is given to be 850, and the adjacent side is given to be 400. And hopefully this looks and feels hyper familiar. Too far, come back. Woo, okay. It looks like Cammie wants me to break it. All right, so we have to get X by itself, and so you know we're going to bring in the inverse. Okay, so we have to apply the tangent inverse, not just to one side, but to both sides. Okay, so on the left-hand side, I have to apply it to the tangent of X degrees. Okay, and on the right-hand side, I have to apply it to 850 over 400. And so we've taken something that looked complicated and broke it down to a very, very familiar problem. Okay, so the tangents by rule will cancel, leaving us with X degrees. And so we have to find the inverse tangent of 850 divided by 400. So we'll make that a decimal first, 2.125, and then take the inverse tangent of it. And so, to see the top of the building, you have to use an angle of elevation, so you have to crane your neck upward 64.799 degrees. Okay, and so that's what my angle of elevation is. This right here, the X is going to be 64.799 degrees. Okay. Let's go to number 2. Let's look at, it's a balloon problem. It's a bouncing balloon problem, apparently. What if I just hit that once? What happens if I just hit you one time? 2 times? 3 times? Tap and tap and tap. Okay, so here we have a classic balloon problem. We saw this is another one where this is a classic kind of trigonometric problem. And so you are in that hot air balloon. So you are right up here, sir or madam, in the balloon. And you know that you're 600 feet above the ground. Where you can see your friend, and your friend is going to be right here. Your friend's on the ground, okay? So your friend is right there. Okay, so you can, if the angle of depression to your friend is 20 degrees, how far is he or she from the point on the ground below the hot air balloon? Okay, and so again, this is set up for us, but we're seeing some very classic elements. The big thing I want to point out is this angle of depression. And so you're up here in this hot air balloon. If you notice, the angle of depression does exactly what I said it was going to do. You look straight out first, and then you look down. Okay, so this is your angle of depression. Okay, so please note, it's not actually inside of the triangle that we're even trying to solve. The triangle, as was given to us, is from the balloon to the ground, over to your friend, and then your sight line back to you. So the angle of depression actually exists outside of the triangle itself, which makes it a little bit tougher because we actually have to figure out an angle inside this triangle. I think we have a couple options. Now, the easiest one to me is understanding that if you look down at your friend's looking back up at you. And so that means there's another angle right here from your friend looking back at you. This is not an angle of depression. This is going to be the angle of elevation. Okay, Here we go. But there is a relationship between the two angles. If you have to look down 20 degrees to see your friend should have to look up 20 degrees to see you. Okay? And so even though the angle of depression isn't part of our triangle, we can use it to find an angle in our triangle. Okay? Now this is getting a little messy for my taste, so I'm going to do a quick redraw here, just so I have a clean triangle which to solve. Okay? And so I need to find this value, question mark, the distance between your friend and the balloon, or where the balloon's above the ground. You're told you're 600 feet above the ground, and then we found out this angle is 20 degrees because the angle of elevation is equal to the angle of depression. Well, that looks like a very familiar triangle to me. And so our steps here are actually very well known. Step one, choose a reference. Well, I'm going to choose this one. Okay, so this would be my reference angle. Okay, label the side lengths. Okay, well, I need to find question mark, but that's going to be my adjacent. Okay, I'm given the opposite, the 600, so this is OPP, and then let's start setting our ratios. Okay, so I know my reference triangle ratio is going to be equal to my actual triangle ratio. Okay, I have O and A to work with, so that's going to be my ratio, O over A. And it should be the same for both my referencing information and my actual information. We're using 20 degrees as our reference to name O and A. And so if I take tangent of 20 degrees, okay, for my real triangle, for 20 degrees, the opposite side is 600. And the adjacent side is unknown, but I want to find it. Okay, so I'm just going to leave it as an A for adjacent. All right, so this is not an inverse problem. I need to find the side length. I actually already have the angle. And so I'm going to convert that tangent of 20 into a decimal, because that's what I I need to solve the problem. So that's going to be 0.3640 if I round properly. Okay, so 36397 is going to be 40 over 1, of course, so we can cross multiply. If you're wondering why I keep erasing the equal sign when my board messes up, because what accidentally gets drawn is a non-equal sign. So if you have an equal sign with a cross through it, that means not equal, and so I have to keep erasing it even though my board's the one that keeps messing that up. It's because it's lagging a little bit. Anyone who ever played video games knows how annoying that is. Okay, so I have 0.3640 divided over 1 is equal to 600 over A. And so I'll cross multiply and solve this bad boy out. And so my A value, the distance between where my friend is on the ground to where I am, or you are, excuse me, in the hot air balloon along the ground laterally, is 1648 plus 3.352 feet. Okay, and so that means this distance is going to be 1648.352. In my original drawing, that's how much it is. Okay, and so the takeaways of this one are a little bit more dramatic, right? The angle of depression is easy to understand once you get the hang of it, but it is a difficult concept to grasp. Most people, pay close attention, most people want to call this angle right here, I'm not even going to mark it in, but the angle from the green line to the black line, most people want to call that the angle of depression. That can't be the case because that implies you were starting to look at your friend, you saw your friend and you went, boop, look straight down. That's not what's going on in the problem. The natural sideline resting point for most people is going to be straight ahead, like they're looking at the horizon. And so the angle of depression, just like angle of elevation, has to start straight out and then go down. So the angle of depression is actually outside of the triangle most of the time. And so we have to convert that to an angle inside the triangle. The easiest one is understanding angle, depression, and elevation have the same angle. Now I know we can also find this little guy right here, okay? And we can find it by understanding that this should be 90 degrees, and so this angle up here should be 70. You don't have to use the angle of elevation, you do have options. All right, anyway, that's part one. We're gonna do about 2 problems per part, so there's gonna be, what, 3 more parts of this? Tackling these word problems, which are my favorite.